All right, this question comes from the area and sector area worksheet. Some students asked for question number 14, which I'm really glad of because 14 is a review of solving by factoring. So maybe there's some students out there that need to see factoring done again, since we will need to know this later on in the semester. So I'm going to solve this by factoring. If I want to find let's cover what solving means. Solving means find the values of x that make the left side equal to the right side. So if I can find the values of x that make this equal to 20, I have solved this equation. And a lot of times on quadratics, you've got more than one solution. So before I can factor, I've got to get all the terms over to one side. So I'm going to do that. This is going to be 3x minus 7x. When I subtract 20 from the right, that's going to make the right side equal to 0. When I subtract 20 from the left, that's going to end up being negative 20. So now I can factor. Usually we look for a greatest common factor, and in this case, my lowest number can be 3. So 3 doesn't go into 7, so that's no good. 3 doesn't go into 20 either, so I've got no common factor because any number greater than 3 is not going to go into 3. But let's try 2. We'll go down 1. So 3 doesn't work. 2 doesn't go into 3, so now I have no GCF. My greatest common factor is actually 1, and that doesn't count. That doesn't change anything. So my GCF, let's write that in a different color so you can see that better. So my greatest common factor is equal to 1. And the reason I write that is because if my A value, my number 3, was negative, I would have to factor out negative 1. Even if my GCF is just 1, I would still factor it out because I have to factor out a negative. If my GCF is equal to 1, then in this case there's nothing I have to do. If I factor out a positive 1, I'm still going to end up with A is 3, B is negative 7, and C is negative 20. So now I have to go through my factoring. And the way we do that is we're going to draw our I table and find our possible combinations. This top part of our I table is always A times C. So 3 times negative 20 is negative 60. And the bottom of our table is B, which is negative 7. So what two numbers multiply to give me negative 60 and add to give me negative 7? I always start with 1. Let's work our way down. 1 and 60. That's never going to add up to negative 7. How about 2? 2 is a factor of 60. 2 times 30. That's not getting us there. Let's try 3. 3 is a factor of 60. 3 and 20 will never add or subtract to get me to negative 7. Let me see. 4 goes into 60. Let's find out. So 60 divided by 4, that's 15. So I've got 4 and 15. 4 minus 15 is negative 11. That's still not getting us there. Let's try 5. Let's see if 5 is a factor. So 60 divided by 5 equals, there we go, 12. 5 and 12, and now we're looking good, class. Take a look. 5 minus 12 is negative 7. So I have found my combination. Now we learned by factoring, we're going to split our B term, and we're going to rewrite this as 3x squared plus 5x minus 12x minus 20 equals 0. All we did was take our B term and split it between our combination. Notice here we cannot use a shortcut. This is not our factored form, x plus 5, x minus 12, because our A value is not equal to 1. All right, our next step. We take the first two terms and we find the GCF. So in this case, my GCF is equal to, it's just x because there is no common factor between 3 and 5. So I'm going to rewrite this as x times 3x plus 5. What did I do here? I removed the x and figured out what do I have to multiply x by to get back to my original 3x squared plus 5x. So x times 3x is 3x squared, x times 5 is positive 5. So far, so good. Let's go ahead and factor the last two terms. So my GCF here is, first thing I'm going to note is I got to make this negative because my first term here is negative. Now 12 and 20. 12 doesn't go into 20, 11, 10, 10 doesn't go into 12, 9, 8, 7, 6. 6 doesn't go into 20, 5, 4. 4 looks good. 4 goes into 12 and 4 goes into 20. So I've got a GCF of negative 4. So there's my GCF of negative 4. What am I left with? I'm left with 3x plus 5. Let's check it. Negative 4 times 3x is negative 12x. Negative 4 times 5 is negative 20. Looks very good. And class, our goal is always to see if we can get these two binomials to be the same. If they are, then I know that I've done a good job on finding my combination. And so now my last factoring step. We will take the two values that we factored out, combine them in their own binomial, and the reason why is because 3x plus 5 is a common factor, and that means we can pull it out and we're left with these two terms, x minus 4. So now I want to find my solutions, and we always use the zero product property. So two things I have to figure out is what changes x minus 4 to 0? That is positive 4. There's my first solution. And then take my second binomial. If I can get that equal to 0, then 0 times this is always going to be 0. Let's subtract 5 from both sides. 3x equals negative 5. Divide both sides by 3. 3 over 3 is 1, so I can ignore that. My other factor is negative 5 divided by 3. So this is a tough factoring problem. I appreciate some students asking this question. There's no shortcut. You got to go through full factoring in order to solve this. I hope my explanation is understandable to you and it helps remind you what we learned last semester.